Hello, 7th grade. This is Miss White, and today we're doing End-Module 2 Study Guide. Number 1. The water level in a local lake changes at an average of -2/11 inches every 6 years. A. Based on the rate above, how much will the water level change after 1 year? Show your calculations and model your answer on the vertical number line using 0 as the original water level. So first is we need to figure out how much the water level will change after 1 year. To do that, we're going to use our rate to solve for that information. So I'm going to take -2/11 and divide it by 6. Now, because we're dealing with a fraction, I need to make sure both of my values are in fraction form. To do that, I'm going to make my 6 an improper fraction. So I'm going to have -2/11 divided by 6/1. Great. Now I have got my fraction set up to divide, and I need to do keep, change, flip. So I'm going to have -2/11 times 1/6. Now I have -2 times 1. Well, a negative times a positive is going to give me a negative value, so -2 times 1 is going to give me -2. Over 11 times 6, which is going to give me 66. Now, because our numerator and denominators are both even numbers, I know that I can simplify them by 2. So now I have -2 divided by 2, and because I have a negative divided by a positive, that's going to give me a negative value, and -2 divided by 2 is going to give me -1. 66 divided by 2 is going to give me 33. Now we need to calculate in decimal form in order to find where we are going to plot on the vertical number line here. So first of all, I know when I set up my equation, I have -1 divided by 33. And we are trying to find the answer in decimal form for that. Let's go ahead and set up our long division. I'm going to have 1 in my box and 33 outside of my box. Then I need to make sure I have my decimals in place with zeros behind it. Now, how many times does 33 go into 1? Well, it can't, so we're going to have a 0 above. How many times can 33 go into 10? Well, none. So again, we're going to put another 0 above. Now, how many times can 33 go into 100? Well, 33 can go into 100 3 times. And then when I have 33 times 3, I'm going to get 99. So now I'm going to have 100 minus 99, and that's going to give me a value of 1. Then I can bring down my next 0, and I'm going to have 10. And because I have 10 now, I know that 33 cannot go into 10, so I can leave it as a 0. Now that I have done the division for this problem here, remember, I have a negative divided by a positive, and that's going to give me a negative value. So my true value here is going to be -0.03, okay? And we do not need the 0 behind there. So now let's look at our vertical number line and on where to plot. So here's the original water level here at 0, and we are looking for 0.03. Here I have -0.1, and then here I know this is where we're going to have -0.05. Well, I have -0.03. So I know that that point is going to be somewhere between my 0 and my 0.05, my -0.05, sorry. So here we're going to label this as -1/33 inches. Okay. All right. Let's go ahead and go on to number 2. So it says, how much would the water level change over an 8-year period? So first of all, we know that per year, the water is changing -1/33 inches. We are going to multiply that by 8. To set this up, so both of our values are in fraction form, I'm going to have negative 1 over 33 times 8 over 1 to keep 8's value. Now I have negative 1 times 8. A negative times a positive is going to give me a negative value, so negative 1 times 8 is going to give me negative 8 over 33 times 1, which is going to give me 33. Okay. Now, usually we want to see if we can simplify, and here we cannot simplify, so this is our answer. Now we know that the water level will change negative 8 over 33 inches every 8 years. Let's move on to number 2. Convert the given fraction into decimal form. Then answer if it's a repeating decimal or a terminating decimal. Justify your answer by using long division. So we're going to want to use long division, and here are our fractions. I know that I have 2 over 15. And when I write 2 over 15 as a division problem, I have 2 divided by 15. So let's go ahead and set that up for a long division. So I have 2 in my box and 15 outside of my box. Then I need to remember to add some zeros and put a decimal over where my current decimal is. Now, how many times does 15 go into 2? Well, that is 0 times. How many times can 15 go into 20? And that is 1 time. 15 times 1 is 15. 20 minus 15 is going to give me 5. Then I'm going to bring down a 0 here. And I have 50. How many times does 15 go into 50? And that is 3 times. When I have 15 times 3, it is going to give me 45. And then I'm going to get 50 minus 45. That's going to give me 5. I'm going to bring down my other 0. I have 50 again. How many times does 15 go into 50? That is 3 times. I know that 15 times 3 is 45, and I'm going to get 5 again. So we can see the repeating pattern here. When I want to write this in decimal form, I'm going to have it equal to 0.13 repeating. Now, is this a repeating decimal or a terminating? Well, because we're using the repeating sign, then we know that it is a repeating decimal. Great. Let's move on to B. Here, I have a fraction of 2 over 16. Now, because both my numerator and denominator are even numbers, I know that they can be simplified by 2. Or 2 divided by 2 is going to give me 1, and 16 over 2 is going to give me 8. Now that I've simplified my fraction, I know that when I do my long division, I'm going to have 1 divided by 8. So let's go ahead and set that up as a long division problem. I have 1 in my box and 8 outside of my box. Then I need to put my decimals where they belong, and I need to add some zeros behind it. Now, how many times does 8 go into 1? Well, that is 0 times. Now I need to say how many times does 8 go into 10? Well, that's 1 time. And 8 times 1 is 8. So now I have 10 minus 8, which is going to give me 2. I'm going to drop a 0 down, and I have 20. How many times does 8 go into 20? And that is 2 times. 8 times 2 is 16. So now I have 20 minus 16, and that's going to give me 4. And because 8 can't go into 4, I'm going to bring down my other 0, and now I have 40. How many times can 8 go into 40? Well, that is 5. And 8 times 5 is 40. So I get an answer of 0. So my dividing is over. Now in decimal form, I am going to get 0.125. Now because we finally got a remainder of 0, that means that this is a terminating decimal. All right, let's go to number 3. Ellie exercises before and after work 6 days a week. She exercises for 1 hour before work and exercises after work. If she works out a total of 18 hours in 6 days, how many hours does she exercise after work? Create a tape diagram to help explain your answer. We know that before work, she exercises for 1 hour, and then after work, we don't know how long she exercises for. So we're going to use the variable A for after work. Now let's create our tape diagram. Because she works out 6 days a week, we're going to create 6 boxes. All right, and all these boxes stand for 1 day. So we have day 1, day 2, day 3, day 4, day 5, and day 6. And out of 6 of these days, she works out for a total of 18 hours. We need to go ahead and put our values in for what we know for each box. So we know she works out 1 hour before work. And then we're going to add A for the amount of hours she works after work, or she works out after work. Now what I need to do is I need to take my total amount of hours that she works out, which is 6, and subtract it by the amount of hours we know she works out in the morning. So I know that every morning she works out for 1 hour, and then we need to multiply that by 6 for our morning weekly total of 6 hours. So now I have 18 minus 6, and 18 minus 6 is going to give me a total of 12 hours. So now we know throughout the week that she is working out a total of 12 hours in the afternoons. Let's take our 12 hours and divide it by 6. So we're going to take 12 and divide it by the 6 days. And 12 divided by 6 is going to give us 2. So now I know that she works out for 2 hours in the afternoon. I can check my work by adding 1 plus 2, 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 and 1 plus 2. And we know that 1 plus 2 is going to give us a total value of 3 for each box. And 3 times the number of days that she's working out, which is 6, is going to give me a value of 18. So our answer is that Ellie exercises 2 hours after work. All right, let's move on to number 4. Mark and Lilia are playing an integer card game. The cards in their hands are shown below. A is asking us what are the scores in each of their hand. So when I write out this equation, I have 3 plus 4 plus 5 plus negative 9. And in Lilia's hand, I have negative 8 plus 5 plus 4 plus 2. So let's look at Mark's hand again. Let's add his positive score. He has a positive 3, 4, and 5. 3 plus 4 is 7, plus 5 is going to give us 12. And then we have a negative value of 9. So we have 12 plus negative 9. 12 plus negative 9 is going to give me positive 3. Now let's figure out Lilia's hand. Well, she only has one negative value, and 5, 4, and 2 are positive values. So we have negative 8 plus 5 plus 4, which is 9, plus 2 is 11. Negative 8 plus 11 is going to give us a positive 3. So we know now that Mark and Lilia are tied with the same score. Let's move on to B. Brianna says that if Mark and Lilia both take away their 4s, Mark's score will be higher than Lilia's. Reed argues and says that Mark and Lilia's scores will be equal. Are either of them right? Explain. Well, first of all, we know that both of them have the same score right now, which is 3. And if we took away their 4s, that means we are adding a -4 because we are taking them away. They're being discarded. So we add -4 to both answers. If we take away their 4s, we know that 3 plus -4 is going to give us -1. And 3 plus -4 here is going to give me -1 as well. So who's correct here? Brianna or Reed? Well, Reed is correct in this problem. Well, if both Mark and Lilia lay down their 4s, then both of their totals will be decreased by 4. Since both of their totals are 3, laying down a 4 would make both of their scores -1. Mark and Lilia's score would be equal So Reed is correct. Let's move on to C. Mark picks up another set of cards that is exactly like each card in his hand. Which of the following would make Lilia's score equal to Mark's? Place a check mark by all that apply. So Mark's score originally starts at 3, but because he picks up another set of cards that is exactly like in his hand, we know that he's adding another score of 3, and 3 plus 3 is 6. So now we need to see how we're going to get Lilia's score, which is currently 3, to equal Mark's score, that is 6. So let's look at the first scenario. I have double every card in her hand. Well, Lilia's score starts at 3. If she's doubling, that means I'm going to multiply 3 by 2, and 3 times 2 is going to give me 6, which is the same score that Mark has. So we're going to put a check mark there. Now, Lilia starts her score at 3. She picks up another card that is equal to 3, and 3 plus 3 is 6. Same score as Mark's, so we're going to put a check there. Lilia's score starts at 3. We're going to pick up a 10. So we have plus 10 equals 13. And then she picks up a -7. So we have 13 plus -7, and that's going to give me 6, which is the same score in Mark's hand. Now we know Lilia's score starts at 3. If we take away her 3, that means we're going to add a -3 because we're taking that 3 away. And 3 plus -3 is going to give us 0. And we're going to take away a 1. So we're going to have plus -1 since we're taking that +1 away. 0 plus -1 is going to give us -1. Now -1 is not the score that Mark has, which is 6, so we're not going to check mark that one. All right. So now it says we take away her 2, so we have 3 plus -2 because we're taking her +2 away. And so 3 plus -2 is going to give us 1, and then because we take her -2 away, that means we're going to add a +2. So I have 1 plus 2 equals 3. Now she still has the same score that she had in the beginning, so it is not the same as Mark's. Then it says, pick up one of each of Mark's cards. We have 3, because that's her starting score, plus, let's look at Mark's cards. Mark has -8, so we have plus -8, plus 5, plus 4, and plus 2. Now, we know that from our problem up here that all of that equals to 3. So essentially, we really do have 3 plus 3, and that's going to give us 6. That is the same scores mark, so we can go ahead and check off that line as well. All right, let's go ahead to the next question. Explain why your selections will make Mark's and Lilia's scores equal. Well, first of all, we know that Mark's total doubles because every card in his hand doubled. So his total is 6. Each choice I selected from above here would add 3 to Lilia's total to make it 6. And that is going to be our answer for this problem. We have Mark's total doubles because every card in his hand doubled. So his total is 6. Each choice I selected, which we selected it by check marking it on the lines, would add 3 to Lilia's total to make it 6. All right, and that concludes our End-Module 2 study guide.